finishing 10.4, and 10.4 is all about the inverses. Okay, so your inverses of your trig functions. Remember that inverses of trig functions are used to find what? Angle measures, right? Okay, so we're going to be using the inverses to find our angle measures. In the first example, we're going to do an application. So we have a painter who is leaning a 30-foot ladder against a wall. The safety guidelines recommend that the distance between the base of the ladder and the wall should be, and then you guys are going to fill in 1/4. Okay, so the distance between the base of the ladder and the wall should be 1/4 of the length of the ladder. To the nearest degree, what acute angle should the ladder make with the ground? So we are rounding to the nearest degree. Okay, and then we have to find the angle. Does the ladder make with the ground? So step one, when you're drawing a diagram, all I need you to do is draw a right triangle, okay? And it doesn't matter what direction it is, so you can pick. It's even okay if it's not completely to scale. So you have the ladder, and then this is going to be 1/4 of the ladder. So we're going to draw a right triangle. I'm going to draw my ladder. So remember, the ladder is leaning against a building. Okay, so that's where the ladder is leaning. This is the picture that we're looking at. We know that the ladder is how many feet?
30.
Great. Okay, and then what else do we know?
7.5.
Is what? The base. So it says the distance between the base and the wall, which is going to be right here, should be 1/4 of the ladder. So a 1/4 of 30, we would just multiply or divide 30 by 4. And like you guys told me, you get 7.5 feet. Okay, so now what we're going to do is find the measure of the angle. So it says, what angle does the ladder make with the ground? So in order to determine what function we're using, okay, we're going to use SOHCAHTOA. Okay, so SOHCAHTOA. Alright, so what am I going to use? The sine, the cosine, or the tangent? Cosine. Why? Good, you know the hypotenuse and the adjacent side. So when you're finding the value of theta, this is the cosine of theta equals the adjacent over the opposite. Okay, this is what we were doing early in chapter 10. But now we're trying to find theta, okay? Okay, so when you're trying to find theta, we have to use inverses. So I'm going to show you what's happening, and then after we do this once, I'm going to show you what steps you can skip. But to separate cosine from theta, there's only one way to do that, and it's not division, never divide. The only way to separate the cosine from theta is to take the inverse cosine of each side. So if you do that, if you take the cosine inverse of each side, what happens is the inverse operations undo one another, so then you would be left with theta. So all we have to calculate is the cosine inverse of 7.5 over 30. Okay, when you are writing this out, I am perfectly fine with you going from here to here, or even just writing this out is fine. Okay, so you can just write out theta equals cosine inverse of 7.5 over 30. Now, we're finding this to the nearest degree, so if I'm using my calculator, what should I make sure? That I'm in degree mode. Okay, so just check your mode. And now we're using the inverse. The inverse is located above the function. So cosine inverse is above cosine. And then we are going to take 7.5 and divide by 30. Okay, now what does this say that we're rounding to? Nearest degree. So that means the nearest whole number. So if I have 75.5, I'm looking at the 10th place to determine what my angle is. So for this one, theta is going to be 76 degrees. Okay, questions for me on example 1? Does this seem a little familiar from things that you've done last year? Finding the angle measure with the triangle? Okay, so example 2 is going to be very similar where we're going to draw a model, okay, and we're going to solve. So a road has a 5% grade, and that means that there's a 5-foot rise for 100 feet of horizontal distance. Okay, so there's a 5-foot rise for 100 feet of horizontal distance. What we want to find is at what angle does the road rise from the horizontal? And this time it says we're rounding to the nearest 10th of a degree. Okay, to the nearest 10th of a degree. Okay, so again, your picture doesn't have to be exactly to scale, but if you're doing a 5-foot rise for 100 feet, okay, we know that the rise is going to be shorter than the run. So like I said, it doesn't have to be exactly to scale. Obviously, the more to scale you get it, the more accurate you'll be able to check your answer. So if it's a 5-foot rise, that's the same thing as the height. So this is going to be your 5 feet. Okay, and then the 100 of the horizontal distance. Anytime it's horizontal, it has to be going on the flat part of the triangle. Okay, whether that's at the bottom and the base or at the top. And then we want to find the angle, does the road rise from the horizontal, which would be this angle here. Okay, now if you look at your picture, right, the angle value, do you think it's going to be a large angle or a small angle? It is going to be super small. And that makes sense, because if you're on a road, do you want to go up a steep hill? No. You'll see the same things, like a lot of problems talk about different ramps, right? If you're trying to build a ramp for people to have easy access, okay, if you're in a wheelchair, you don't want a really high ramp. That would be really difficult to get up. Yes?
I'll do like a 3 degree.
Oh, did you find it? Okay, so what are we going to use? The tangent, sine, or cosine? Tangent. So we have the opposite and we have the adjacent. Okay, so we know that the tangent of theta is equal to 5 over 100, which means theta, we're using the inverse. Okay, and it does say that we're rounding to the nearest 10th of a degree. So if you are rounding to the nearest 10th, what place do you look at to tell you whether you round up or stay the same? The hundredths, great. Okay. All right, so I have 2.86, which is going to be approximately what? Good. All right. Questions for me on story problems? Finding the angles in story problems. Okay, like I said, in geometry, I know that you cover that. Okay, the rest of the stuff that we're doing today is going to be new. Some of it is going to tie into yesterday, and they're also going to be tied to a unit circle. Okay, was also going to be tied to your homework yesterday, so I am going to talk about that as well. So in example 3, we're going to solve each equation to the nearest tenth. And then you have to use the given restrictions. So every single problem is going to have some restrictions. We talked about these special restrictions yesterday when we were dealing with the inverses. Do you guys remember what some of those restrictions were yesterday? If you had the sine inverse, do you guys remember what quadrants it was?
1 and 4.
Yes, good. So Q1 and 4. Do you guys remember cosine? 1 and 2, and yes, so tangent and the sine inverses are the same. Okay, there is going to be a special pattern that we're going to notice with these today. Okay, so the first one says the sine of theta equals 0.4. So today we are going to work with decimals. Up until this point, we've been working with really nice values on the unit circle. Okay, there are values on the unit circle that are not exact, and they still exist. We're going to explore some of those today. So we want to solve the sine of theta equals 0.4 with this restriction, from negative 90 to 90 degrees. Okay? So for the first couple problems, we're going to use a visual representation, which is what we did yesterday to talk about the quadrants. So we're going to draw a circle. And negative 90 is going to be here. 90 is at the top. So if you are going from negative 90 to 90, what quadrants does that entail? Good. Quadrant 1 and quadrant 4. All right. Then your next step is to write the equation and solve for theta. So write the equation and we're going to solve it for theta. All right, so if this is our equation, how are we going to find what theta is? What do we have to do to both sides? Oh, you tell me. How do you undo the sign? Yeah, you take the inverse. Okay, so remember, when you're taking the inverse of each side, the reason why you're doing that is because that's the only way to get theta by itself. Okay? So those are going to cancel. Theta is going to equal the sine inverse of 0.4. So let's find that. Okay, and then this says that we are rounding to the nearest tenth. So we're going to find this to the nearest tenth. Okay, so can you just check on your calculator, make sure you got the same thing that I did. And this is going to round to 23 point what? Yes, 23.6 degrees. Okay, now the next thing you have to do is you have to ask yourself, is this in between the given restrictions? Okay, so what you're asking yourself is theta between negative 90 and 90 degrees. Okay, so is 23.6 between negative 90 and 90? Yes. If the answer is yes, you are done. If the answer is yes, you're done. So theta is 23.6. This question is theta between negative 90 and 90. So you don't have to write out on your homework is theta between negative 90 and 90, but I would definitely make sure it's in your notes so you understand when we stop at step 2 and when we have to do another step, okay? Because the next one's going to be a little bit different, okay? Okay, so before we start on the next one, I am going to just talk about something that you would have seen on your homework last night. So yesterday we were finding where certain values were on the unit circle. Okay, and there was one where you had to find this value. I can't remember if it was sine or cosine. Let's just say it was, you had to find where the sign was -1/2, okay? So the point here is √3/2, -1/2. Do you guys know what this point is on the unit circle? Yes, good, 11 pi over 6, okay, which is what in terms of degrees? 330, okay? Now, if you wrote this down and you went to check in the key, it did not say 330 degrees, and that's because, like you guys told me, the sine inverse is in quadrants 1 and 4, but the specific description says it's from -90 to 90. So is 330 in between 90 and -90? No, but you can rewrite it so that it is. Yeah, what is this angle here? 30 degrees. So how could you write that? -30. Okay, so if you were checking and you're like, oh, I have 330, why doesn't the key say that? It's because they're rewriting it so it's in the range. Okay, so -30 degrees and -pi over 6 would be the same. So today we're going to do something similar. Every single angle has more than one name to it. We are going to have to remember how we plot our angle measures, which is what you guys did in 10.1 and 10.2, right? So if I were to draw an angle, I'll use the same one, okay? This here is 330 degrees. That's the positive name. But this angle here is -30. So they end at the same place, but they just have two different names. We're going to be using that today. Something else we can note is the reference angle. What's the reference angle for -30? 30. What's the reference angle for 330? 30. So today we're going to be using some reference angles. And that's what we're going to do for part B. So for part B, the sine of theta is equal to 0.4. Does that seem familiar? Does it seem familiar? No. It should. I know, I'm sorry. I do math the musical. Okay, so 90 degrees is less than or equal to theta, which is less than or equal to 270. So this equation is the same. The only difference is the given restrictions. So if you are drawing this visual representation, stay with me, this is going to be new. Okay, we start at 90 degrees, we go to 270. What quadrant or quadrants start at 90 and go to 270? 2 and 3.
Why is it different?
This is 90 to 270. So this is something different. What do you mean? Oh, you start where they tell you. So see how it says it's 90 is less than or equal to theta, which is less than or equal to 270? So did you see when I drew it that I went like this? You start at 90, you go to 270. That's the part of the circle that you're going on. Well, pay attention if you're confused.
No, I got it. I'm picking up what you're putting down.
But are you? Okay, so the two quadrants are quadrant 2 and quadrant 3. Okay, so step 2 is the same where you write the equation and you solve for theta. Well, we already did that, so we're just going to write the sine inverse of 0.4 gives us 23.6 degrees. Okay, so this is exactly what we had before. You're doing the inverse, but now when you're asking yourself, is it in between the restriction, what's your answer going to be? No. So is theta between 90 and 270? And if the answer is no, then you have to find the proper equivalent angle in the correct quadrant. Okay, so if your theta value is not in between the given restrictions, that's okay. You have to find the equivalent angle. To help you understand this a little bit better, I want you to think about this equation that we just looked at and think back to what we were doing yesterday. So remember yesterday we talked about how there's more than one place on the unit circle where your sine value is negative 1/2? Yeah, because we know that there are places where the y value is negative 1/2, right? Can you guys tell me what quadrant the other one's in? Using all students take classes. Okay, for negative 1/2 for sine, y3. Yes, okay, so in this one, the y coordinate would be positive 1/2. In this quadrant, it would be positive 1/2, because it's a y, right? So y is positive above the x-axis. You guys with me with that? Okay, so then it would be negative here. So see how there's two places on the unit circle that both give you negative 1/2? If you did your homework yesterday, you would have written some of these down, right? You have to have you have pi over 6 plus 2 pi n, and then you have 5 pi over 6 plus 2 pi n. You were doing equivalent ones. There were two places that you had to write down. So for today, that's what we're going to use. So yeah, there's more than one place where this happens, but we can use a reference angle. So we were just talking about reference angles. See how this reference angle is 30 degrees? That's what this reference angle is, 30 degrees. So what we're going to do is we're going to find the equivalent place in the correct quadrant. So this is how we do that. We're going to find the angle that's either in Q2 or Q3. That's specific to this problem because it says it has to be between 90 and 270. Okay, so that will change based on your problem. So find the angle in Q2 or Q3 that has the same sine value as 23.6 degrees. That means your reference angle is 23.6. Okay, so the first thing we have to do is narrow it down. We have to figure out if it's in quadrant 2 or quadrant 3, because that's going to change our picture. So we are going to use the all students take classes. So if you can jot that down, that would be great. And then we're also going to use our original equation. So the original equation that we have says the sine of theta equals 0.4. All we have to do is look at this, okay, 0.4, and all we have to figure out is it positive or is it negative? So is that positive or negative? Positive. Okay, so if this is positive, what you have to do is find the quadrant where sine is positive. So is sine positive in Q2 or Q3? Q2 is correct. Okay, so that's what we're going to use. Okay, so again, we know it's in Q2 or Q3 because the sign is a positive value. It has to be in Q2 because in Q3, this would be a negative value. Okay, now that we have that, all we have to do is draw our reference angle. Okay, so this is going to go back to how we set up reference angles. Remember, reference angles always go to what? X-axis. Good, okay? So if I'm in quadrant 2 and I want to draw the angle 23.6, the reference angle, 23.6 is going to be approximately here. $23.6. Okay, what you have to find is the angle that starts at the initial side, because remember when we drew angles, we always start at the initial side and we go to the terminal side. All you have to do is find that angle. So we drew the reference angle, you have to find this angle. How can we do that?
180.
Good, 180 minus 23.6. Okay, because if you look at it, don't these two angles together equal 180, equal 1/2 of the circle? Yeah, so 180 minus 23.6 is going to be what? 156.4. And is that in between 90 and 270? Yes. Okay, so your answer for theta is 156.4 degrees. That's your final answer. Okay, so your final answer should be in the interval. Okay. I know, it's going to take, we're going to do this a few times, and I know it's going to take some time to seep in. Yeah. Tony?
You have to do all that extra stuff then, because once you find out that it's conflicting with the 90, 270, then you just have to subtract it. Or, well,
No, because it depends on the quadrant. Yeah, so that is going to change depending on the quadrant.
Like if you know which quadrant it's supposed to be.
Yes, if you know what quadrant it's supposed to be in, there are some patterns that you'll be able to pick up on. Yeah. Okay, so for C, we're going to do the tangent of theta equals -2 for -90 to 90. Okay, and if you like drawing the visual, you can absolutely do that. If you guys are getting pretty good at understanding what quadrants those are, you can also just start right away by identifying those quadrants. So -90 to 90, do you guys know what quadrants that's going to be?
1, 4.
Okay, good. So Q1 and Q4, okay? So in order to solve, all we have to do is the tangent inverse of -2. Okay, and like I said, this is what I want to see. I want to see how you're getting your value for theta. Okay, so you're writing your equation down. So the tangent inverse of -2 is -63 point what? 0.4. Okay, so we're still rounding to the nearest tenth. Okay, so then you're asking yourself, is this between -90 and 90? Yes. So we're done. Now, I want you guys to think about what types of problems you don't have to go on. Is there a pattern between them? So this one was the tangent. Okay, and this is between -90 and 90, so we don't have to go any further. It also happened with the sine. It also happened with this first sine. Is there a correlation we can make between them? Remember what we talked about earlier today? The sine inverse has what restrictions? 1 and 4. And see how this had the same restrictions? Okay, so this had the same restrictions as the sine inverse. Do you guys remember another name for the sine inverse? Starts with an A. Arcsine. Okay, so that had the same restrictions as the sine inverse. We didn't have to go any further. Is this the same restrictions as the tangent inverse? Yeah, this is the same as the tangent inverse. Okay, so that's not a coincidence. If they're the same as the inverse, then you shouldn't have to go any further. So negative 90 to 90 is for tangent and sine inverse functions. And then cosine would be from what? Good, yes, 0 to 180. So this is negative 90 to 90. This one is 0 to 180. This one is negative 90 to 90. Okay? Okay, and you guys probably will just ask yourself, is it between that? That's okay. Alright, so for D, you have the same equation where the tangent of theta equals negative 2, and then your restriction is from 90 to 180. So what does that cover? Yeah, that's just quadrant 2, okay? If it's just one quadrant, that does happen sometimes. Consider that a gift, because if you have multiple quadrants, then you're going to have to figure out which one it's in, but if this is just quadrant 2, that's really going to help us out, okay? So we just found this above, so we can just write theta equals negative 63.4 degrees. Tony, do you have a question on this one? Okay. Just hold on a minute, okay? So for this one, your equation is the same, so theta is negative 63.4. And then you just, again, ask yourself, is this between 90 and 180? No, it's not. Okay, so when it is not in between those, okay, that means you have to use a reference angle. So it's not between 90 and 180. Okay, so we have to use the reference angle of 63.4 degrees. Now, the reference angle is 63.4 degrees because remember, when you're doing a reference angle, they're always what? They're always positive. Okay? So, what we're going to do is we are going to draw the reference angle in which quadrant? 2. Okay, so if you draw the reference angle in quadrant 2, 63.4, you do need to have an accurate representation of where that is. Okay, so 63.4 is going to be somewhere in this region. Okay, so it should be more than halfway. So what we just did is we graph the reference angle. The angle that you have to find is going to start at the initial side and go to that same place. Okay, so it starts at the initial side, goes to the same place. Okay, so how do we find that angle? Yeah, again we can do the 180 minus 63.4. Now the reason why we can do this for both of them is because both of these ended up where? They both ended up in quadrant 2, okay? And you can look and see. Together they would make 180, right? So for different quadrants, there are going to be different rules. If you end up in quadrant 2, you can subtract it from 180. and you should get 116.6 degrees. Okay, and is that in your range, your restriction? Okay, so theta is 116.6 degrees. All right, we're going to do one more, and it's the cosine of theta equals 0.778 for 180 degrees is less than theta, which is less than 360. Have some of you noticed that sometimes they're less than and sometimes they're less than equal to? Okay, that's really not going to affect your final answer. It just means that if it's equal to, it could be 90 degrees, it could be 270. Okay, but that's not going to affect your process at all. Okay, so go ahead and do your first steps. So all of these have the same direction, so here's 10. Yep. So I feel like we're doing a really great job of finding our theta value. So the cosine inverse, what did that give you for theta rounded to the nearest 10th? Yes, 38.9 degrees. Okay, now remember, this is going to tell you what quadrants are your options. So 180 to 360 entails what two quadrants? Okay, good. Now, to determine if we're going to put this in 3 or 4, because this is not in the restrictions, right? This is not between 180 and 360. All we have to do is look at the sign of the original problem. So this is what we look at. Is that positive or negative? Positive. So we have to ask ourselves, where is the cosine positive? So in 3 or 4? Yep. So now we're going to draw our reference angle in quadrant 4. So it's 38.9 degrees. So 38.9 be about there, maybe a little less than that. Okay, but what you are trying to find is the angle that starts at the initial side and ends at the terminal side. How can I find this angle? Yeah, so see how together they make 360? So you could do 360 minus 38.9. And you should get 321.1 degrees. So that's going to be your theta. Okay, so remember that it is based on your reference angle. Okay, and then 321.1 just fits in